Now we have to discuss the file input and output where we will learn the following objectives. Okay, first, data items can be stored in two broad types of storage devices such as the volatile and non-volatile storage. Volatile storage is temporary that such as those stored in variables. The values that are volatile are lost when a computer loses power. And usually, the random access memory is the temporary storage within a computer. Non volatile is permanent storage, and the value will not be lost when a computer loses power. A computer file is collection of data stored on a non-volatile device. And files exist on permanent storage devices such as hard disks, zip disks, USB drives, reels or cassette tape, or the compact disc. You can categorize files by the way they store data, whether text file or binary files. Text files contain data that can be read in text editor because the data has been encoded using the scheme such as the ASCII characters or the Unicode characters. Binary files contain data that has not been encoded as text. Their contents are in binary format, which means that you cannot understand them by viewing them in a text editor. Some text files are data files, and data files contain facts and figures such as the payroll file that contains employee numbers, names, and salaries. And some files are program files or application files that store software instructions. You have created many such files throughout your operations. When you store a permanent file, you can place it in the main directory or root directory of your storage device. If you compare computer storage to using a file cabinet drawer, saving to the root directory is equivalent to tossing a loose of document into the drawer. However, for better organization, most office clerks place documents in folders and most computer users organize their files into folders or directories. And a complete list of disk drive plus the hierarchy of directories in which a file resides is its path. Now, when you work with stored files in an application, you typically perform the following tasks, like determine whether a file exists or where a path, open a file or write information to a file, read the data from the file, close the file, and delete the file. And Java provides built-in classes that contain methods to help you with these tasks. You can use Java's path and files classes to work with stored files. The path class is used to create objects that contain information about files and directories, such as their locations, sizes, creation dates, and whether they exist. The file class is used to perform operations on files and directories, such as deleting the file, determining their attributes, and creating input and output streams. You can also include the statement in a Java program to use both the files and path classes. And the NIO package in Java um, stands for new input or output because its classes are new. So in that, they were not developed until Java 7. To create a path, you first determine the default file system on the host computer by using statements such as file system if s is equal to file systems that get default. This statements creates this statement creates a file system object using the getDefault method in the file systems class. The statement uses two different classes, the file systems and the file system class without an ending s, and is used to instantiate the object file systems with an ending s is a class that contains factory methods which assist in object creation. After you create a file system object, you can define a path using the getPath method. With path, an object path is equal to fs.getPath with specifying this path of data with a file name, data, and extension .txt. Recall that the backslash is used as part of an escape sequence in Java. For example, the C / Java backslash chapter.13 backslash data.txt. After the path is created, by the way, every path is either absolute or relative. Absolute is a complete path. It does not need any information to locate a file on a system. A full path, such as this one, is an absolute path. Whereas the relative path depends on other path information. A simple path such as data.txt is relative. Now, when you work with a path that contains only a file name, the file is assumed to be in the same folder on the program, as the program using it. This table summarizes several useful path methods. So as you have learned with the other classes, toString method is overridden from the object class. It returns a string representation of the path. And basically, this is the list of path elements separated by copies of the default separator for the operating system. The getFileName method returns the last element in a list of path names. And frequently, this is a file name, but it might be a folder name. Now here, it uses the toString method to show the output whether the file name, the path declaration exists. And here, the file name is data.txt. So as you can see in this directory, data.txt is the file name. And there are three elements in the file path. The element 0 is Java, and element 1 is chapter.13, and The element 2 is data.txt. Okay, now take note of the method names being used here. The get name count, okay, which shows the um, names associated with this directory. And here there are three name counts: 1, 2, and 3. And there are three separations for this directory. Remember that the backslash character is used as an escape sequence to write a double backslash. So for a double backslash, you need to use for using or printing the single backslash, we need the escape character sequence of backslash. So the two backslashes are here being used. All right. Now, toString is being used to display the path name. Okay. And of course, being used with the object of file path. And get file name is being used to display the file name. And here is a loop which displays repeatedly the name of the elements starting at the element 0. Starting from the element after the root directory and displaying the name. Now, converting a relative path to an absolute one by the use of toAbsolutePath method. So this method converts a relative path to an absolute path. For example, this program asks a user for a file name and converts it to an absolute path. So if where this program resides, the path being saved for this program will be the absolute path. So it is where the data to be created will be stored. Okay, and of course, the NIO package will be used for this absolute path. Okay, so of course, okay, the path class is being used and the object input path. A input path is used to get the name of the path and to convert to its absolute path. We have the method to absolute path. Okay, where the value after being converted to absolute path is being stored here in the full path. And this full path is used to get the directory of this path. And it's here. So let's try to demonstrate. Let's try to run. Now we are asked to enter the file name. So for example, the file name is sample data.txt. Now, after the data is being get and assign it to the variable name, it's being assigned with a path, and this one is used to convert to its absolute path. So as a result, getting the directory on where the program is located, the directory is being converted to its absolute path where the newly created file is being saved. Now checking the file accessibility. Okay, we need to verify that the file exists and that the program can access it as needed. So we can use the check access method with which the import statement, okay, will be needed. Okay, just to allow us to access constants that can be used as arguments to the method. And let's assume that we have declared a path named file path to check the access. So we need to use this one, file path dot get file system dot provider dot check access, with the arguments file path, read, and execute. So you can use any of the following arguments to the access method. The read argument checks that the file exists and that the program has permission to read the file. And this write, another argument that will be used is the write argument. Write checks that the file exists and that the program has permission to write the file. And this execute has to check that the file exists and that the program has permission to execute the file. Take note that static import feature here takes effect when you place the keyword static between import and the name of the package being imported. So this feature allows us to use static constants without their class name. So for example, if you remove the static from the import statement for this Java file access mode, you must refer to the read constant by its full name as access mode.read. Okay? So instead of read directly, so using this file access mode.read. So when you use static, you can refer to it just using the read argument. So as an alternative to using check access with no argument to determine whether a file exists, so you can substitute the file that exists method as path argument. Now, to delete a path, the files class delete method is used to accept a path parameter and delete the last element in a path. Okay? And or throws an exception if the deletion fails. Now, in this case, if you try to delete a file that does not exist, no such file exception is being thrown. And a directory cannot be deleted unless it is empty. So if you attempt to delete a directory or that contain files, a directory not empty exception will be thrown. Now, in determining the file attributes, you can use the read attributes method. Okay, so we have here the read attributes method of the files class to retrieve useful information about a file. The method takes two arguments, okay, a path object and the other one is this basic file attributes dot class. And this one returns an instance of the basic file attributes class. So we can create this statement for returning the instance of the basic file attributes class. The time methods in the path demo 5, so in this sample program snippet, returns a file time object that return a file time object. Okay, return the file time object that is converted to a toString with the method being used as println method. So file time object is represented in the format year, month, date, um, time in hours, minutes, and seconds.